What is up, guys? We're going to be taking a look at this lab, Samesite lacks bypass via cookie refresh. This is a cross-site request forgery attack where we change the email on the victim's account. However, the cross-site request forgery aspect of this lab is really straightforward, and if you treat this just as a regular CSRF lab, I think you're missing the point. The purpose of this lab is to give you a feel for how OAuth works, and we're going to be following that aspect of this lab through step by step before we perform the cross-site request forgery attack. Now, let's just speak really conceptually about what OAuth is. It's really about giving the keys, or at least a temporary key, to a web app so that it can use a service on your behalf. As an example, imagine that you have some photos uploaded to Google and you want to be able to access those photos through a web app. Now, one thing that you could do, which is obviously a very bad idea, is you could just give the password to your Google account directly to the web app so the web app could log in for you and access your photos. Obviously, not a very good idea. Another thing that you could do is you could download all of your photos from Google and re-upload them to the web app. This is okay, but there's obviously a lot of work involved. What we actually want to be able to do is to give temporary access to our photos to the web app. And this is what OAuth does. Now, in this particular lab, it's a type of blog, but the profile is actually going to be stored in our OAuth provider. So you can think of it as being Google, but the reality is it's not Google in this case, but in the photos example, Google was the OAuth provider. And the idea is when we access our profile from the web app, it's not necessarily stored on the web app. The web app has to take our profile from the OAuth provider before it can display it to us. In other words, we're giving access to the OAuth provider to the web app so that it can utilize the resources we have on the OAuth provider on our behalf. Now, let's take a quick look at how the authentication flow for this works. And it's something that you've probably seen on many occasions. It's something that's fairly typical to how the modern web works. If I click on my account in the web app, notice I'm not taken to a login field hosted on the web app. I'm actually given a login form provided by the OAuth provider. By the way, this also allows for something that we can refer to as single sign-on. If you've ever attempted to sign up to a new web app and it gives you the option to sign up with Google or sign up with Apple, this is an example of OAuth. It's allowing you to leverage existing credentials with your OAuth provider in order to create a new account at the web app. So it's not necessary for us to create new credentials for the web app because it's making use of OAuth. So this idea of providing identity is something that's fairly specific to OAuth. In fact, the identity part of things is really an add-on, which is referred to as OpenID, which is part of OAuth. But a big part of OAuth, or OAuth 2, which is what we're using at the moment, is this idea of allowing a third-party access to your resources. So in this particular case, we're seeing an example of both identity provision, but we're also seeing access to files on a third-party site because the web app here is going to access our profile on the OAuth provider. Now, first of all, we need to log in. We're given some default credentials for this. Wiener, Peter, let's sign in. And you're probably familiar with this screen as well. So it tells us now what we're allowing the web app to actually access because we don't necessarily want it to access all of the resources on the OAuth provider. There's what's referred to as a scope. So the web app is allowed to access certain resources or perform certain functions on our behalf when accessing information from the OAuth provider. So in this case, it's saying we like to blog is requesting access to your profile and your email from the OAuth provider. Now, notice that it's not requesting identification. So although this is using OpenID, it's not saying we want to access your identity. And that's because that's usually implicit with these types of authorization windows. So it's just required to tell us what's being explicitly accessed outside of that, the profile and the email in this case. So we've authenticated with the OAuth provider, which in turn means that we end up authenticated with the web app itself. And in the background, the web app is allowed to send requests to the OAuth provider and retrieve information such as our profile and our email, as we've just seen. Now, that's the high-level overview of what's just happened. We're going to jump into this at a slightly lower level and take a look at the OAuth flow. So the very first request we make is to / my account. We're not authenticated at this stage. We can see a GET request, and the web app is going to take a look at that session token to establish whether or not we are logged in and authenticated with the OAuth provider. Now, once it sees that we are not authenticated, the next thing it does is it hits us with a 302 redirect. You can see the location header is set to / social login. So it realizes we're not authenticated with the OAuth provider. It sends us to another part of the site where we can now authenticate. So we're at / social login. Let's take a look at the response. Now we're actually hit with a meta tag here, which has a HTTP equiv equals refresh attribute. So you can see that here. This is maybe a little bit less common knowledge, but this is going to function as a redirect. In this case, we can actually use meta tags with attribute HTTP equiv equals refresh. And you can see the content there. That's where we are being redirected to. We have a URL there. And it's good to just take a quick look at that URL, because within the query string of that URL, we have a number of parameters that are included. In fact, let's take a look at the next GET request. The other interesting thing to note is that we've actually jumped domains here. So we're no longer at the domain of the web app itself. If we take a look at the host, you can see that we're now being sent to .oauthserver.net. So we've hit login.social, it's redirected us now to the OAuth provider, and it's provided some parameters as part of the query string. Let's just take a quick look at those parameters. So first of all, after the question mark, we have client ID. Now that's actually the client ID of the web app. So that's not going to change. We then have a redirect _ URI. That's going to tell us where to get sent back after the OAuth flow has completed. And notice that's back at the lab itself, websecurityacademy.net. Response type equals code. This is sometimes referred to as a grant. So the idea is we're going to authenticate with the OAuth provider. We're going to get this code or grant, which is then going to allow the web app to submit a request for a token. The token is going to be temporary access to the OAuth account. Then also notice we have scope. So this tells us what's actually being requested. What is the web app allowed to use as part of this OAuth connection? And you can see it's requesting OpenID. So that's actually the identity provider service, OpenID. We have two other items requested in scope, profile and email. So ultimately, this is going to generate that confirmation box. This is what the web app is trying to access on your behalf. Do you accept that? Then of course, afterwards, the code and the corresponding token are going to give the web app access to those resources. So now let's take a look at the response. We get another redirect. We get a 302 found response. Notice that headers are setting cookies. So we have this _ interaction, which is really a tracking ID to track this particular OAuth flow to see where we've reached, because there are different stages to this. Obviously, at this stage, we haven't yet authenticated with the OAuth provider. We're just setting up the parameters, saying, here's our client ID from the web app. This is the scope that's being requested. So once we've given that information to the OAuth provider, it's then going to send us on a redirect. We have location / interaction. And then you can see that we're passing that cookie value as part of the URL. So we're clearly visiting a route that's specific to this particular OAuth transaction. So next we've submit the GET request to / interaction / the interaction ID. And it's just easier to render the HTML here. You'll see where we've reached in the flow. We have a sign-in box, but it's clear that although we appear to still be on the Web Security Academy page, this HTTP request has been sent to the OAuth provider. The form is provided by the OAuth provider. And if we take a look at the form itself, we can see that it's posting back to the OAuth provider. So you can see it's posting to / interaction, our interaction ID / login, and it's naturally going to post the username and password that we provide to that endpoint. So now we can see the post request to the login endpoint. As part of the post request body, we can see the provided username and password. We have our interaction cookie set, although it may not necessarily break the functionality if we didn't, because as we can see, it's actually also included in the URL as well. But for this particular setup, we can see it's included both as the cookie value and also in the URL itself. So we post our login credentials to that endpoint. We get a 302 redirect. This time we're sent to /auth followed by our interaction ID. So now we're at /auth interaction ID. An important thing to note here is we've just submitted our credentials. We've been redirected to this route. Usually this happens if the login is valid. And as part of that, we're actually given a session cookie, session ID. Take a look at the response. We have set cookie _session equals followed by our session ID. Now, the important thing to note here is that this is the session cookie or session ID with the OAuth provider. We're also going to have a session ID or cookie with the web app itself. Now, just to make things a little bit easier, the OAuth token is called _session. So the token that we get from the web app is just going to be called session, but the token that we get from the OAuth provider is called _session. So we can see now we're actually logged in with the OAuth provider. And of course, HTTP is stateless, but given that we have that cookie, it's as if there's state. It's as if we are logged in with the OAuth provider. So now when it redirects us to /interaction /interaction ID, this is actually a route that we've visited before. It's just that when we hit this route previously, we didn't have the _session token, so we weren't authenticated with the OAuth provider. So at that point, it asked us for our login credentials for the OAuth provider. Whereas the second time, when we visit the route, after the redirect, it recognizes we're logged in. You can see we are submitting this _session to the OAuth provider. And the easiest way to understand what's happening now is let's just render the response. We're now at this authorization stage. So the OAuth provider is saying, okay, you're authenticated with us. You have the right to choose what happens to your data. Now let's deal with this request to access your OAuth data. Do you agree to allow the web app to access your profile, your email, and also your identity as provided by OpenID? So we have the option to click the continue button there. And if we check out the underlying form, action is going to be /interaction, interaction ID /confirm method equals post. So the very next thing we expect to see is going to be a post request to /interaction, interaction ID /confirm. So that post request is sent. The backend is going to acknowledge that now we've authorized the web app to access our OAuth resources. So it sends us with a redirect. We're now heading to /auth /interaction ID. Again, this is a route that we've visited before, but we can see each time we've come back, we've had different tokens set, different things have happened as a result. But now our browser is being sent to /auth /interaction ID. So at this point, we've given permission for the web app to access our OAuth information. But in order to do that, the web app needs a token to make requests to the OAuth provider. Now, we don't give the token directly. Remember when we first made the request to the OAuth provider, we were asking for a code. Response type equals code was one of the parameters given as part of the query string. And that's what we get back here. So we're actually hitting the OAuth provider for the last time because the OAuth provider is now going to hand us back to the web app. It's just that it's going to send us back to the web app with the code itself. So you can see redirecting to, we have a URL that resides in the web app, but we then, as part of the query string, have this code parameter. Now, making use of this code parameter, what's going to happen in the back end, and we're not going to see this because this is going to happen server side, is that the web app is going to use that code or that grant to make a request to the OAuth provider for a token, which it can then use to access our information. And associated with that token will be things like the scope that it's allowed to request access for and other security features, such as a timer on the lifetime of the cookie. So although we're providing access to the web app to access our OAuth information, it's only going to be for a temporary period of time, at which point reauthentication is going to be required. Now, in a sense, that code has simply just come to us at this stage. The web app is not aware of that. That's why our very next request, which is where we're redirected to, is going to be to /OAuth callback. Keep in mind now that the location is on the web app itself. Query string, code parameter, the value of the code. So now what happens in the background is that the web app is going to take that code, it's going to submit a request to the OAuth provider, it's going to get a token in response, and then it's going to get back to us after that, and it's going to provide us a session token for our session with the web app. So notice that we have a session token now with the web app. You can see this header set cookie along with our session token. But remember, we also have that session token with the OAuth provider, which is still valid as well. So anytime you make a request to the web app, it's going to submit our session token with the web app. And anytime you make a request to the OAuth provider, it's going to submit our _session token to the OAuth provider. So that would be useful if we need to re-authenticate at any point. For example, one of the things that we can do right now is we can log out of the web app. So our session token will be destroyed or actually replaced in this case. That's generally considered a good security practice, by the way. Rather than destroying the user's token, you actually replace their token with another token that represents a non-logged in state, but the session is still active. So for example, here in the lab, if I head to my account, we can see that our email is weena@normaluser.net. So we can access our profile information. Now we'll talk a little bit about the email a bit later, because where does that email come from? Presumably it came from the OAuth provider, but then the interesting question is, if we try and change that email, which email are we changing? Are we then changing the email on the OAuth provider as well? Or is this just changing the email on the local app? So we'll get to that shortly, but for now, let's just log out. So what's happening here is that our token has been replaced with the local web app. So we are no longer authenticated with the web app, but that doesn't automatically get rid of our token with the OAuth provider. So now if I head to my account, first thing it does is hit that /social media login endpoint, but it realizes that we're already authenticated with the OAuth provider. So notice we immediately get the message, you have successfully logged in with your social media account, and we can choose continue. Now, one of the important takeaways from the context of how the cookie is set and the fact that it doesn't have a Samesite attribute, so we know that that's going to default to Samesite = lax after 2 minutes, is that we have the ability to quickly re-authenticate with the OAuth provider. And of course, in turn, that means we're going to be provided a new session token from the web app itself. So you can see that this re-authentication flow happens quite a bit more quickly, at least in terms of number of requests, than the original authentication where we were not authenticated with the OAuth provider. Just to look at this quickly, we hit my account. Web app checks locally to see if we are logged in. Now notice that there is a session cookie. There is an active session, but it's representative of a logged out user. That's a new session token that we received after logging out. So the web app realizes straight away, hold on, this user is not authenticated. We need to authenticate this user. How do we authenticate the user? Well, we don't do it locally. We use the OAuth provider for that. So we now need to send the user to /social login. Social login is the route that redirects us with those meta tags and the HTTP equiv attribute. It attaches a few different parameters to the GET request. And after that, it sends us on to the OAuth provider. So we get sent to /auth on the OAuth provider. It's just that when our browser sends that HTTP request to the OAuth provider, guess what? We're already authenticated with the OAuth provider. And also, what does our browser do? How does the OAuth provider know we're authenticated? Well, it sends that _session token along with every request to the OAuth provider. So the OAuth provider looks at this and instantly realizes, hold on, this user is already authenticated with the OAuth provider. We really don't need to do a lot here. Let's just give the user the code that the web app needs to generate the token. So we get immediately redirected to OAuth callback. Remember, that's back on the web app side of things, and attached as part of the query string is that code parameter. And already we're handed back to the web app. So now let's take a quick look at this session token that's given to us by the web app. So we have the set cookie header, and then we have the value of the session token. What we don't have here is a Samesite attribute. What that means is that it's possible for this particular session token to be sent cross-site. So if the victim is authenticated with the web app and visits an attacker-controlled domain, it's possible to dispatch a post request and the browser is automatically going to include the session token. At least it is for 2 minutes. So as a quick recap, why do we say 2 minutes? Well, there's no Samesite attribute set. So that means in a modern browser, Samesite is going to default to lax, but only after a period of 2 minutes. Now, the reason why all of this is relevant is because if we try and execute a cross-site request forgery attack after those 2 minutes have elapsed, it's going to fail. That's because Samesite will have defaulted to lax, so only certain types of requests are actually going to include that session token. So we're not going to be able to change the victim's email with the cross-site request forgery attack. But here's the thing, we've seen that as soon as we send the victim to that /social login route, the rest is automatic. If we assume that the victim is already authenticated with the OAuth provider, we can actually induce the browser to set a brand new session token without the Samesite attribute set, which gives us a 2-minute window to utilize a cross-site request forgery attack. So we can actually include that as part of our attack. The victim lands on the attacker-controlled domain. The first thing we do is we send the victim to /social login. The full OAuth procedure is going to take place, resulting in the victim being assigned a brand new session token with the web app, and then immediately dispatched is the post request to the change email endpoint. We know at that stage, because it's instant, we're within that 2-minute time window. Samesite is basically set to none for the duration of those 2 minutes. We can send as many cross-site post requests as we want to, and the browser will include the session token as part of that cross-site request. Now, that doesn't guarantee that the change email endpoint is vulnerable. So we're just assuming that it is at this stage. In fact, we know it is because it's a vulnerable app. But in the real world, that doesn't guarantee that the change email endpoint is vulnerable. For example, it might be protected by a cross-site request forgery token, in which case, even if the browser does attach the session token automatically, we don't know the value of the cross-site request forgery token unless we have some kind of other attack vector in place, such as cross-site scripting. So let's take a look at this functionality. And I think probably the temptation with this lab is to start the lab at this point. So we have none of that context of the OAuth. And this just maps as a regular cross-site request forgery attack from this point onwards. But I think the purpose of the lab is to get that context of we're operating from within an OAuth framework. So let's take a look at the regular functionality. We're just going to make up an arbitrary email. We'll choose update email. We can see that our email has now been updated to newemail@newuser.com. Let's take a look at the requests that were sent to the backend. So here we can see the post request to /myaccount /change email. We can see the new required email as part of the post request body. We can see that the session token is included because without that, the request is going to fail. What is the key piece of missing information in this post request? There's no cross-site request forgery token. So there's nothing to prevent this particular request originating from an attacker-controlled domain unless the Samesite attribute on the cookie is sent to lax or strict, in which case the session token is not going to be included. Now, we already know that it's possible to include that. We've seen how the session token was set. It was not set with the Samesite attribute. So we know for 2 minutes, it's going to act like a cookie that has Samesite equals none, and it's going to be dispatched along with any post request that originates from an attacker-controlled domain. So the very fact that there's no cross-site request forgery token in this post request means that there is a cross-site request forgery attack vector in place. We just need to set things in motion. So here is where we get to the exploit server, which mimics the attacker-controlled domain. The idea is we place a payload on the attacker-controlled domain. The victim visits the attacker-controlled domain. The attacker-controlled domain dispatches a post request. Now, what we're seeing right now is a vanilla example of the cross-site request forgery attack. So at this stage, we don't, first of all, send the user to /social login. So we are assuming that we're in the 2-minute time window. There is an extra piece of information here, which is history.pushState. This is really just designed to conceal the exploit. But if you actually experiment with this particular lab, it doesn't actually add anything to the exploit whatsoever. So it's really just there as some sample code. Sometimes this is included in cross-site request forgery attacks, but in this case, it may as well not be there. So what we have is the absolute basics of the cross-site request forgery attack here. It submits the post request and it includes a new email as part of the post request body. Now, it is important that you place your lab ID as part of the form action here. I've already done that. Let's store this and view the exploit. For us, when we've tested it on ourselves, we actually have a new email set. So the next stage is to try this out on the victim. Now, it is important that we change the email value because we can't set the victim's email to the same as our email. There's going to be some kind of error in that case. So we've set a new email here. We'll choose store again, and we'll choose deliver exploit to victim. We'll see if the payload works. Now, the idea here is if you do this within 2 minutes, it's going to work. But if you take a look at the lab walkthrough, it's a fair bit more complicated than that. The reality is that every time I've done this, I've just needed this very basic snippet to actually trigger the lab flag. But the walkthrough does allow us to touch on some slightly more advanced concepts for this type of cross-site request forgery attack. So let's take a look at the lab walkthrough. So we have the basic exploit here. Honestly, I think it's a mistake to include history.pushState because it doesn't have any impact on the lab. So I don't think it's a useful teaching tool in this case. But the idea is for certain types of attack, you may be able to use history.pushState to conceal the fact that an unintentional request has been dispatched from the browser. But in this case, since it's a post request followed by a 302 response, I don't think this actually makes any difference to the output. We then have 2 additional sections, so this might seem like it's a really complex, detailed walkthrough broken down into 3 sections, but the reality is the first section, in fact, even a fragment of the first section, is enough of a payload to actually solve this lab. So let's take a look at what the other 2 sections are actually talking about. So the first is entitled Bypass the Samesite Restrictions. So we've already spoken about this. It's the idea that if this doesn't work, it's because maybe the browser has already defaulted to Samesite equals lax in its handling of the session cookie. So the key difference with this particular payload is that it first of all dispatches a request to /social login. Now, if the user is already authenticated with the OAuth provider, then obviously the end result is going to be the automatic provision of a new session token with the web app. And from that point onwards, we then call document.forms@index0.submit. So that auto dispatches the post request to the change email endpoint. So just in case that session token with the web app has already defaulted to Samesite equals lax, this particular payload ensures that that's refreshed if possible so that the cross-site request forgery attack completes. We then have this bypass the pop-up blocker section, which is really just an add-on to the previous script in case the previous script doesn't work. And it seemed to me that the previous script did work, so I'm not really convinced there's necessarily a need for the extension to the script here. But the problem that's supposed to be being solved here is that a feature of some modern browsers is they won't pop open a window unless there's been some kind of user interaction on that page first. So this prevents us from visiting an attacker-controlled domain and being hit by hundreds of different pop-ups, for example. So we can see that that second payload actually makes use of the JavaScript window.open. The problem is, though, if the victim hasn't interacted with the attacker-controlled domain in any way, then that /social login window is not going to pop open. Therefore, it's going to be impossible to refresh the token. So we can see this third payload, which I really don't think you'll need in order to solve the lab, is designed to engineer around that problem. But it also downgrades the cross-site request forgery attack in the process because a really simple heuristic or principle is that we always prefer attacks that are automated and don't require user interaction. So we'd prefer it that the victim lands on the attacker-controlled domain and instantly the change email route is hit and the victim's email is changed. This downgrades that slightly because it now requires the victim to click on the page. So the idea is we say window.onClick. So there's an event listener there, assuming the victim does click on the page, then call window.open, and that pop-up is going to be loaded. It's not going to be blocked by the browser because the browser sees that there has been some type of interaction with the page. And you can see there is actually a HTML paragraph which is designed to encourage the user to click on the page. It says click anywhere on the page. The victim clicks on the page, window.onClick event listener is triggered, which then calls window.open, which hits the / login route. The session token with the web app gets refreshed. The post request to / change email is dispatched. The victim's email address is changed in the background. So really, in summary here, what would I actually recommend? I would recommend that you simply use this particular code snippet, paste in your lab ID to solve the lab. But just understand that actually solving the lab is fairly arbitrary here. This is just a very basic vanilla cross-site request forgery attack. The point of this lab is to understand the context of the attack within that OAuth authentication flow. So take the time to look through the various GET requests and POST requests and session tokens that formulate the OAuth flow in this lab. That's actually the main takeaway here, and the cross-site request forgery attack really just finishes things off here. I guess one of the takeaways from a defensive perspective is just because you're using OAuth does not automatically mean that your web app is secure. You still need to make sure various routes are protected. And let's just revisit one question that we posed during the lab as well. When the victim's email address gets changed, does that mean it's also changing the email address on the OAuth provider? And if the answer is no, then is it a problem that the user's email with the web app is now going to be different from that email that's provided by the OAuth provider? So the simple answer is no. The user's OAuth email does not get changed, which then means that the user's email provided by OAuth and the user's lab email are actually two separate identities. However, this is fairly typical behavior. Some web apps might force you to stick to the email that's provided by the OAuth provider, but in other cases, you may be able to set your email separately with the web app. In other words, the web app is still going to store some information on you. It's going to store its local version of your email address, which could be different from the one that's provided by the OAuth provider. It's going to associate that local web app email address with the OAuth account, but they could be different. Another thing that I like to touch on very briefly in terms of OAuth functionality is once the web app has access to that token, it doesn't necessarily have to keep going back and forth from the OAuth provider, because it could sound really inefficient on surface value, which is every time we make a request to the web app then has to dispatch a subsequent request to the OAuth provider. For example, to retrieve our profile. Every time we ask for our profile, then there's another request that happens in the background to the OAuth provider from the web app, gets our profile, returns to the web app, then finally gets sent back to us, the user. But the web app also has the ability to cache some of that data. So it's not necessarily a very inefficient model. Once the web app has retrieved that information from the OAuth provider, it can then cache that locally and can use that information directly in communication with the client's browser. Another question you might have about OAuth is whether it's possible for the request for information from the OAuth provider to originate directly from the browser. See, the setup we're describing at the moment is we send a request to the web app then server-side sends a request to the OAuth provider, and then gets back to us, the client. Is it possible that the web app could actually instruct our browser to send the request to the OAuth provider, retrieve the information directly to the browser? And the answer is yes, it can do that. It's just slightly less common, and it's generally considered slightly less secure, but it's actually possible to have setups that do both. Possible to have a setup where the backend communicates with the OAuth provider. It's possible to have setups where the user's browser communicates with the OAuth provider. It's just that in most cases, it's typically the web app that's going to be sending a server-side request to the OAuth provider, and then to increase efficiency, probably caching some of that data and storing some of that data locally, such as the user's email. So that can then be changed on a local level and doesn't change the email address that's been given to the OAuth provider. So I think that's really the main takeaway of this lab, is just getting a deeper understanding of how OAuth works. It's a very common paradigm in modern web apps. Chances are you are going to be testing a web app at some point that's making use of this OAuth flow. All right, that's pretty much it for this lab. Thanks very much for checking out the content, and I'll catch you guys in the next lab.